Hello, I'm Salman Rahman. So today I'm excited to present our project on the design and remote control of a maximum power point tracking system with the solar pumping system for Bangladesh weather. So this is the coursework for the instrumentation and the control system. So here is our content of the for this presentation. Introduction, literature review, benefits of our this system, and how we design our system and all the components request to the design. And then we have done a simulation with the Homer Pro and the MATLAB prototype. And yeah, we done a small prototype version for this for our project. And then the conclusion and the future work we have and reference as well. So let's get into the introduction. So at first we have to select a location from Bangladesh. So for our project purpose, we select the location is Faridpur Sadar Upazila. It's in Bangladesh. It's the southern part of the Bangladesh. And then we use the Homer Pro and the MATLAB system design for a simulation, as I mentioned before. And by doing this Homer Pro simulation, we get the estimation for the PV module, and then we have calculated the total output and analyzing the load profile depending on our solar pumping system and its capacity. And finally, we have estimated the battery backup for 2 days or 3 days, whatever the consumer want to take the backup from the battery. And here is our small literature review. We find a few more different papers related to our presentation topic. Like it's quite similar, but not the exact one. Some of them are working in 2019. It's IoT-based and automated solar irrigation system. And after that, some of them working with generating electricity from PV and monitoring water levels and the soil moisture and so on. And the other group, they work with smart IoT system for monitoring solar PV power condition in 2016. And in 2012, they're using Arduino Uno and GPRS modem for remote monitoring with the embedded system and the irrigation system. Okay, that was a small summary of our literature review to our project. And this is the main interesting thing why we need to do this project. What is the benefits? What is the outcomes from we get find from this project? So we can use the photovoltaic solar panel to generate the green energy, green electricity, and we can convert the sunlight to electricity. And as well, we use the submersible pumps as our as for our irrigation. And this will ensuring a reliable water supply. And the remote control capabilities is like utilizing the Arduino for control and Bluetooth modules for the wireless communication, allowing for the efficient and the remote management of the system. So here is our design methodology, how we gonna think to design this system for that location. So here you can see there is our site map. It's from the Google Map. So this red circle area, red marked area is our land to place the PP panel, and then we design an Homer Pro system. So you can see here there is an electric load. This is mainly our uh, solar pump, and then here is a converter for if there is something happened with the rain or the cloud, then we must have to take the backup from the grid system. And there is the battery and the PV panel. So, and oh yeah, and here is our load profile, monthly load profile, uh, depending on depending on the weather and the demand of the irrigation. So from the Homer, we find this kind of solution. Like Homer suggested us to it's required 30 batteries with 10 in parallel string and 3 of in series uh, because our solar pump has capability of 36 volt. It can do the maximum 36 volt it can run. So we combine the three 12 volt batteries to get 36 volt output from there, and then we attached parallel 10 parallel string with that. And for the solar panel, we use 290 watt panel, PV panel. So we need six panel. uh, so we will connect two panel in string and three panel in series to get to match the bus voltage for the system. And this is the Homer design and the suggestion from the Homer. We get the idea about our batteries, and then we get our idea about the PP panel, how much panel we need, and how we uh, combine the panels. And here is our system components, what things we need. So here is our solar pump. This is an PV panel. This is an Arduino Uno, and is the Bluetooth device for remote control system. So this is our simulation result after Homer. From the very first picture on the above left side, this contains the solar irradiance of that specific location. So the irradiation was about average 3.8 kilowatt hour per meter square per day. So you know the Asian country uh, is a bit sunlight country. So we get the sun and the irradiance for more than the irradiance in Canada or otherwise. And the second picture, it contains the output from our PV array. It's is output in the kilowatt and is from the total whole PV array. I mean, from our system. And the bottom left picture, it contains the net total generation from our grid purchase and from the solar PV panel and then the battery system. That's all are integrated in the same graph. And the bottom right, the last picture contains the monthly electricity production from that system. So it's varied month to month because you see there is a small slope on July to August because of maybe there is an possibilities of the rain or the cloudy. That's why we do not need to run our pump for the rainy day or the cloudy day. So in that time, we can store the energy in the battery, or we can use the energy of the battery for other purposes if we do not need to run the pump for the cloudy or the rainy weather. And here is a simulation result from the MATLAB. We also simulate our design in MATLAB. So it's just the MPPT portion for the system. So here you can see the top picture. It indicates our MATLAB design. So we use their NPI controller MPPT design. So it suggests and corrected our output and maintain the output always within the 36 volt. As you know, I mentioned it's 36 volt of to run our pumping system. So here is the design. We written here a MATLAB function and then PI controller and the other stuffs like PV panel and then battery and mm, the IGBT and other instrument as well. And the immediate picture, it shows the input voltage from our PB array, how much input we will get from our PB array. So it should like near about 36 volt or a bit more than 36 volt. And for the current, we see the left bottom picture. It shows the input current for our PB what we will get from our PB array. So the input current is a bit higher because we add the multiple PV panels uh, in series connection. In parallel connection. So in parallel connection, the voltage would be same and the current will be higher. So we have to match the total output voltage with our solar pump. That's why we have to connect this in parallel. And the right to picture indicates the output voltage from our PV array and output current from the PV array. So it shows that our load, I mean our pump will consume near about 3.5 ampere, yeah, 3.5 ampere, and it will runs within 35 volt. Yeah, and the graph shows an smooth graph of 35 volts. So it's only for the MPPT. This will correct our this will correction for the output voltage as we have required for the system. And this is the prototype design for our remote control system. So the first picture shows the connection diagram, I mean the circuit diagram for this system. Like here is the motor. This motor shows represents our submersible pump and the batteries. And here is an IC. It's mainly called the motor driver IC, and there is an Arduino Uno, and then there is a battery. And there is a complete prototype system how this will work and how the how the work we can manage. So if someone connect the Bluetooth device with their phone, I mean if the user or the farmer or the landowner, if he or she connect the Bluetooth device with his mobile with our system, then the system automatically inform that the person, the user, that how much moisture in the soil and uh, what's the water level, and when should I run the water pump, and when should I stop it. So the user will get all the information from that system. And yeah, and then conclusion, we may say the solar powered water pumping system presents a particular and scalable solution for the rural country like Bangladesh, and it has significant potential to reduce the carbon emission and operational cost, and then enhance the agricultural productivity and provide a reliable water supply. Yeah, and then we have some mm ideas about the future work on this project. So what should we do in future, or what is the future addings we can do with this project? So for the integrated IoT and the cloud platforms to enhance the remote monitoring and the data management system, and for the battery optimizing system, we can do reliability during the low sunlight periods, and the implement we can implement the pilot project in diverse location to access the scalability and further optimize to the system, and investigate to the cost reduction strategies such as as local component manufacturing. Then we can reduce the cost as well, and developing the comprehensive training programs for the local users to ensure the effective operation and the maintenance for the system. And here is the references as we have used in this project. And thank you for your time and attention. So that's all for my project.